It is the bending of light. When the light bends, so okay, all of you, please speak this word. Refraction is the bending of light. Speak out, unmute yourself and speak out. Refraction is the bending of light. Burundin,
Refraction
Sasha.
is the bending of light.
Yes, refraction is the bending of light. And that is why, see, this experiment is simple. I will send you all these experiments in a little while, and please perform them later on. Yes, Burundin, you have a query?
Sir, I have a doubt, sir.
Mhm.
Sir, my teacher told that light only travels straight. How does the light bend, sir?
Light, Burundin, yes, it travels straight. So, Burundin, which class you are currently in?
Sir, third.
Third, okay. So, Burundin, light travels in a straight line only if you are traveling in one medium. One medium as in, if let's say, if the light is traveling only in air, then it is going to be in a straight line. If it is traveling in water, again, it is going to be a straight line. But if you go from air into water, then the bending happens. Are you getting the point? Otherwise, the light always travels in a straight line unless you change the medium, air into water, water into air, anything the light will bend. Make sense, Purandar?
Sir, like how now we did the arrow, the
Mhm.
air and water both changed the direction of line, so only the arrow changed direction.
Correct. It is because of the water, Purandar, that the light is changing, the light is bending, right? Okay. So let me elaborate on this a little bit. The next application of this experiment. Now, again, I want answers from all of you. So right now, see what is it? We have a candle which is behind the glass container. So you have a candle behind the glass container. And now tell me what's going to happen if we pour, let's say if we pour water on that glass container, what is going to happen to the candle? Will it invert or will it not invert? So let me go back to the experiment. So watch. When we put water inside the candle, remember, is behind. So what's going to happen? Will the candle be inverted? Will it become bigger or will it become smaller? Yes, Burundan. Burundan, you are only responding. Others, Sasha, Myra, Mahadev. Okay, please. Yes, Myra, I want an answer from you. Tell me.
I think it will become smaller.
Okay, Myra is saying it will become smaller. And let's see. And Burundan, you had a point to this. What is going to happen to the candle? Will it become? Yes, yes,
Sir,
go
it
ahead.
will be the same, sir, because when we pour water, the light is straight, sir, so it can't bend. So it will be the same, sir.
Okay, let's see. Let's see what actually happens. In the previous case, you saw the arrows were changing direction. So have a look. When you put water inside the candle, watch. Okay, what is happening? Look carefully. Is the candle became a little bigger in size, right? Let's play this again. Initially, the candle had a specific size. Look at the size of the candle. It became bigger, right? So, but it is not changing direction in this case. See, the arrows were changing direction, but the candle is not. So, again, what's happening here? Does this experiment work selectively? Does it work sometimes? Does it fail sometimes? The arrow was inverting, the arrow was changing direction, but the candle is not. Anyone? Just take any random guess. What could be the reason? Okay, let me give you a simple experiment explanation to this. So have a look. Okay, have a look, all of you. This is the explanation view of the same experiment. We have a small kangaroo cartoon and we will put it behind the glass container. So watch carefully. Look at the image of the cartoon. Okay, so now tell me, let me ask Sasha. So please tell me, right now, is the kangaroo the same or is it changing direction in this?
Is it not? It is
no changing direction.
It is
It's
not
just like
changing.
a big. Yeah,
Yes.
it's like big. I don't know. I can't like it's big.
It is big, but it is not changing direction, right? But if I take the glass and put it away from the cartoon, so let me explain what the experiment is. Let's say if this is the cartoon and this is your water. If you increase the distance of the glass container from the cartoon, then the reversion will happen. The inversion will happen. Let's see. All right, so have a look. Right now, the cartoon is very close to the glass container. And then let's watch this. We are shifting the glass container, and now watch, the cartoon inverts, and also it is changing direction. Now it has changed the direction. Remember? Because watch, initially the ears of the kangaroo were towards the left hand side, but afterwards look at the ears of the kangaroo, they are towards the right hand side. So the inversion has happened. Yes, Purandin, you have a query?
Sir, is it like the shadow when we are close it's big and when we get far it gets smaller? But this
Could
is
you
with water. That is only with light, but this is with water.
Yes, this is with water. So partially, yes, you are right, partially, but just partially. Myra, you have something to add here? Yes, Myra, go ahead.
Also notice that the further the glass, the kangaroo also becomes slimmer.
Yes, yes, right. So see, the reasoning here is the distance of water from your cartoon. That will tell you either the image will be inverted or it will be reversed, right? So please perform this experiment later on when I send you the videos. The experiment is simple. Let me play this one more time. So the cartoon, you can take any object and put it behind the glass. You will see that initially the object is not changing direction. It's bigger, but slowly you can see the image completely inverts. And see, this is because of refraction. And what was refraction? All of you quickly tell me, what was the definition of refraction? What did we learn? Unmute yourself and tell me what was refraction. Refraction.
Refraction is bending of light.
Correct. Refraction is the bending of light, because of which the arrows is changing direction. The cartoon is changing direction. Okay. Now the next experiment is the best experiment of today. So who can tell me, is there a way in which you can make any object invisible? Let me repeat. Is there any way in which you can make any object invisible? Let's say I take any object and I want to make it invisible. Is this even possible? Yes, Purandin.
Invisible cloak or green screen?
Okay. So Purandin, Harry Potter. Have you seen Harry Potter movie? So the cloak, that is a imaginary thing, not possible, the cloak thing, but is practically in the real world. Is it possible to make any object invisible? Yes, Myra, you have something to say? Yes, Myra?
I think if you put oil in the water and then you put a glass, then it will become invisible.
Okay, good. You are thinking in the right direction. There is one way. So, Mahadev, I can see your answer no. So, making an object invisible seems like impossible, but it is possible. So, let me show you how do we do that. We do that using refraction. So, we will make an object completely invisible. So, one sec. So, all of you, please pay attention. This experiment is the most crucial for today. So, right now on your screen, what can you see? We have a napkin, and on a napkin, we have 3 coins, 3 simple coins. What is the experiment? We will make the 3 coins invisible. So the coins will be in front of you, but you won't be able to see it. That's the experiment. right? So watch carefully. How does that work? I'll explain in a while. How do we do it? First of all, so right now, all of you, can you see the coins? Just tell me, right, yes in the chat box, right? Good. So now just have a look. How do we make it invisible? So what do? We take another glass container. This is a glass container, right? And then look at the magic. If you put water into it, when you put water into it, where are the coins? Can you see the coins? They are invisible completely, but they are there still. Right? That was the experiment. So one more time, let's see. The apparatus was simple. You just put a empty glass container on top of the coins. Right now also you can see the coins. All of you please pay attention. Right now, no water is there. You can still see the coins. But when you put water into it, have a look, the coins become invisible. The coins are still there, bear in mind. The coins are behind. So watch carefully. See, here are the coins. But through water, you cannot see it. Right? So this was the experiment in which you can make objects invisible. Now, who is going to take a guess? How is this even happening? How is the object getting invisible? Does anyone know this? Just take a random guess. That's the most fun experiment. Okay, so Niti, Divya, Jaden, Aspi, Amandeep, Minu, anyone just take a random guess? Myra? Yes, tell me.
I think because you are putting the water, there is a glass and then another water and
Mhm.
like that.
Okay, so again, you are thinking in the right track, Myra, good. But let us understand how is this even happening. See, this is an application of same thing, refraction. What was refraction? Please tell me again, what was refraction? What was the definition? Yes, Niti? Niti, yes, go ahead.
Light.
Refraction is the bending of light. So how are we able to make an object invisible? Let us understand it. Now, in order to understand, okay, let me ask you a simpler question. Who is going to answer this? How are we able to see an object? We are going to answer how to make an object invisible later. But first tell me, how are we able to see an object? It's light, right? Without light, you cannot see. Okay, so let me just give a simple explanation. Okay, Burundin, you have your hands up. Anything to add here?
Sir, I have a doubt, sir. What
Tell me.
happens if we move the tissue paper?
Doesn't matter. Tissue paper is irrelevant, Burundin. Tissue paper is irrelevant. That is, see, okay. See, the surface was black only so that you can see the coins clearly. We had placed a napkin. Otherwise, napkin is not at all important. Right? Napkin has no role to play. But the glass container with water, that is the thing which is making object invisible. Let us understand why is this even happening, right? Bending of light. Okay. So all of you have a look at your screens currently. This answers why objects are visible. How do we see objects? That is because of reflection. Okay, now again, have a look at this picture and just explain it to me. What is going on in this particular picture? I want an answer from all of you. Be quick. Look at the picture, analyze, and tell me what is going on. Yes, Myra.
The light bounces off the object and then reflects back into our eyes.
Awesome. Brilliant, Myra. Yes, Mahadev. Anything to add?
The man is wanting to see the flower and the bee,
Yes.
and because of light and by the sunlight of the sun, the man is able to see the flower and the bee.
Brilliant. Awesome. See, the answer, the reasoning is again, you need a light source to see anything, right? But have a look at the second image. what we have done in the second image is you have put something